Hello, everyone. We're excited to have you here. We want to welcome you to Flatiron School's Cyber Essentials, Coding Demystified using Python. My name is Corey Mickelson, and I am the Marketing Events Coordinator here with Flatiron School. A big part of my job is hosting these free introductory workshops, like this evening's event, to give you all the opportunity to meet some of our instructors and get a better feel of the Flatiron School experience. So a quick reminder, the chat's going to be used as our main source of communication tonight. So go ahead and make sure that little blue button at the bottom is switched from host and panelist to everyone so we can all chat together. So without further ado, I'd like to introduce our host for the evening, Mr. Joseph Gallowix. He is one of our lead cybersecurity instructors. Go ahead and take it away.
Good evening, everyone. My name is Joseph Gallowix. I'm here in Rochester, New York. I saw at least a couple people are in my neighborhood posted in the chat. So welcome to my neighbors and everybody else that's tuning in from wherever you're at. I'm one of the cybersecurity instructors here at Flatiron School. Glad you could join us. Appreciate your interest. And what we're going to do tonight is a bit of an intro both to cybersecurity, but also to Flatiron School as well, and our approach to cybersecurity. This is not a hard coding lesson by any means. This is as far as Python or any sort of programming is concerned, but it is a high level view of the nuts and bolts of programming that, like I said, I like to demystify the things that I do. A lot of stuff that students come to us interested in learning, like the various parts of cybersecurity seem mysterious at first, but actually broken down into smaller pieces, it's easy to handle. And that coding and programming is no different. So a little bit background about myself. I'm one of about more than a dozen cybersecurity instructors here. We all have various different backgrounds coming from all sorts of different places. Interestingly enough, just a few hours ago, we had our annual Flatiron Value Awards online. We're pretty much a completely online organization now, and everybody is everywhere, works from everywhere. But we have a really tight community, and we believe in our Flatiron values. If you visit our website, we talk a lot about those. And one of those is being a lifelong learner. All of our instructors, as far as I can tell, across all four of our disciplines, are constantly renewing themselves, constantly doing different things. Myself, I'm a Navy veteran from back in the day. I have a master's degree in information technology, as well as a more recent one in cybersecurity. And in between there, I also have a law degree and a New York law license, and I'm licensed to practice law in New York State. That may seem a little weird, but actually cybersecurity and the law go hand in hand because of the security part and the governance and policy stuff that we get into in pretty depth. So, I'm a legal nerd, and I love this stuff, and I love teaching. Again, back to the rest of our instructors, they all have eclectic backgrounds too, various ways that they've come from the arts, from science, from a variety of different disciplines. It fosters a really rich environment for us to teach in. So each of our different disciplines, just to cover that real quick, just in case you're interested, we certainly have cybersecurity, but we have the other three: product design, which focuses on web and application design, interfaces, that sort of thing. Software engineering, that's where the real heavy duty coding gets into bigger projects and things like that. Cybersecurity and the like. And so we're going to focus on cybersecurity here, and I want to give you just a little bit of a view of what that actually means. A lot of people don't realize what cybersecurity entails. And first off, let's just cover that and what we cover, because when we do cover our program, which is 15 weeks long, in the normal live version. We also have a flexible asynchronous program that you can sign up for that's more self-paced. You can find out information about that on our website as well. Let me share my screen. There we go. And if can you see my screen? Just want to make sure you can see my screen. So again, coding demystified using Python. And let's talk about what cybersecurity is, because most people really don't know. We hear a lot, and it's a lot easier to, thank you there, Jim, I appreciate that. It's a lot, most people can get the idea of what software engineering is, what product design is, that sort of thing. However, cybersecurity covers a lot of bases. Programming is certainly involved, but so is cryptography, which is some heavy duty math. So is what we call human engineering, which is really the way crime has been done for literally millennia. Nothing in the cybersecurity world, curiously enough, is really new in terms of crime and havoc that people cause in each other's lives. It's just new tools, new ways of doing old things. If you're stealing money from someone's bank account, you're still stealing money. You're just using computers to do it. If you're defacing a website, you know, it's no different than taking a spray paint can to a wall. You're just doing it online. So the real difference is just that we're working in the digital world. So because of that, we cover lots of bases, where software engineering is a very, very tight program. Ours actually covers about 8 different topics that mirrors the track that most boot camps follow as well, because it is close to some of the cybersecurity certification programs that are out there, like Security Plus, and the bachelor's and master's programs that are featured in many computing schools across the world, including the university here that I've taught at. So let's take a look at that. Skill areas for cybersecurity. Basically, this is the 8 topic areas that we cover: governance, risk, and compliance, threat intelligence, applied cryptography, network security, system security, application security, logs and detections, meaning security information and event managers, and then Python scripting and programming. So let's take a look at what each of those means. And we're not going to focus on this for very long, just a few minutes, and then we'll get into the coding aspect of what we're going to talk about tonight. So governance, risk, and compliance are what we also call GRC. May not sound like the most important thing, but actually it's at the top of the list because it's the thing that governs and drives everything that we talk about here. What it basically means is, how do we govern and run a business or an organization? Whether that is, you know, a mom and pop corner store. If you think about it, a small bodega or family-owned corner store somewhere, you know, they've got inventory, they've got security, they've got payroll, they've got cash flow, all sorts of stuff is being run by computers. Nobody's running that stuff by hand anymore. And, you know, a store that we might take for granted, walk by every day or drop in and get a sandwich and a coffee, you know, they're moving a lot of money. And if that's a family-owned business, it's important to them. And running that is a skill, and it's important to make sure that it's secure. No different than running Amazon or Microsoft or the cybersecurity issues that go there, or for a nonprofit, or for a law enforcement agency or the military. All the stuff is the same. It just applies different places, different levels of complexity. So our course addresses all sorts of topics, include, you know, as far as securing such an enterprise, including planning, policies, different roles people play, how we measure success and failure, how we manage risk, how we anticipate or avoid risk, how we respond to risk, standards, regulations, and laws, and business continuity when disasters strike. All of that stuff needs a plan. And because of that, That's why GRC is important, because it's from that planning that all of the rest of the technical stuff flows. When you watched a movie or you've seen a TV show like Mr. Robot or something that features hackers and cybersecurity and all that stuff, it usually looks like, people just sitting at keyboards looking at a bunch of code and stuff like that. But really, that stuff is an essential part of the business enterprise. And everything that enables those sorts of things that people do and that funds the parts of the business that make things happen is an essential business function. And so governance, risk, and compliance is central to what we do. Threat intelligence, what does that mean? Understanding what's out there, understanding the problems. If you don't know what the problem you're trying to solve is, it's going to be very difficult to solve it. And because of that, focusing on analyzing and planning ahead of time in order to understand the threat environment, which changes constantly, we focus on threat intelligence. Applied cryptography. If you look at your browser somewhere, depending on the browser that you're looking at, the address bar, there should be something that says HTTPS and maybe a little lock or something like that. Most of the time, you should be browsing the internet on a secure connection. That's driven by cryptography, which is heavy-duty math. We don't get into this into the level that one would in the university course. This is more like applied cryptography, not the sort of research cryptography that's you do if you had a 4 or 5, 6 year program, but enough to apply these ideas on a daily basis and understand how they affect what we do. Network security. Everything we do is over a network, whether you're sitting at home like I am on a Wi-Fi connection, whether you're wired somewhere, whether you're sitting in a coffee shop, you're on a network somewhere. And there's all sorts of protocols that make all of this stuff that we take for granted nowadays work. And that's this alphabet soup of protocols listed here. And that's the reason we deal with cybersecurity, is because there are networks. If there weren't networks connecting our computers at blazing speeds the way it is today, this wouldn't be an issue. 30 years ago, when the internet was and the World Wide Web and all of this stuff was brand new, security wasn't that big a deal. Now it is, and that's given rise to all sorts of levels of crime, state actor havoc, and because of that, the opportunity of employment. Some of you, I dare say, are probably here because you read that there are great jobs in cybersecurity, and there are hundreds of thousands of them, and we try to help prepare people for them every day. Because of that, you got to know networks inside and out. System security. System security focuses on the computers themselves, the actual architecture, operating systems, and the tools that we use to actually run things. Basically, systems administration. So there's network administration that makes networks work. But what makes your Mac work? What makes your Windows machine work? What makes your Linux box work? Your server, whatever you got, whether it's a phone, whether it's your tablet, even your TV set nowadays. If you're like me, and hopefully you're not, because I had way too many internet connected toys now, and I pretty much lost track of how many there are. Everything is on a network and possibly vulnerable to an attack. So system security is all about locking everything down, whether it's your desktop computer or your smart light bulb. Application security. Okay, so we just talked about a whole list of devices. Well, software runs on those devices. That's applications. That's actual software that runs on these devices that makes things work. And this is where the real fun stuff is. If there's a part of our course that looks most like what you probably think of as the stereotypical hacker out of a movie or TV show, that's application security, actually sitting and doing application security and penetration testing. actually going out on a network and looking for vulnerabilities, learning how to exploit them, and also how to defend against them and how to harden machines so that threats are not a danger, or at least those dangers are minimized. Logs and detection. One of the ways we deal with the massive information that flows through all of our systems is through logging. Logging meaning that any machine, whether it's your Windows PC that you might be sitting at, whether it's an iPad you might be sitting somewhere watching this at, anything can be used to record the activity that happens on it. And by using those sorts of recordings, we can kind of like a surveillance camera, go back and determine what's happened if something happened. And that's where we sort of dip into what are called SIMs, which are massive packages of software that allow us to search through terabytes worth of information easily to find out the evidence that determines what happened in a given event. And also, this is where we start dipping our toes into artificial intelligence, machine learning, and the like, because there's so much information that no one person could possibly deal with it on the fly. And so the systems that we use, like Splunk and Microsoft, IBM QRadar and Microsoft Sentinel, and others like it, harness AI to help us detect and prevent events. And so that brings us to Python scripting and programming, and why we're here for that. And the reason we're here for that is, in the end, all of this stuff is based on software. And like I said, we have a software engineering program that will turn you into a software engineer. In our program, we don't. But having enough programming chops under your belt is good on a practical level for what we call scripting. There's a difference between scripting and programming. Scripting means basically writing a series of relatively short instructions for a computer that you can use to make repetitive tasks automated and much easier and efficient. Because a lot of what we do in cybersecurity is reviewing many things. Could be millions of documents, for example, looking for a particular phrase, for example. A script is a very handy thing to do. Instead of going one at a time, we use a computer to write a script that opens each document, looks through it, finds what we need, and then closes it and moves on and records all that stuff. A properly written script can do that in seconds, where a human could never ever accomplish the task. That is a specific, very focused type of programming, and scripting is used across the IT world, whether it's cybersecurity or administration or a variety of other different things, to accomplish relatively short tasks. Then the line between scripting and programming, I use those two words here, although there's kind of a blur. Scripting is programming, it's just lightweight programming. I use the term programming for full-size applications, anything from a simple web application that you might have on your phone that you've downloaded from someplace, or a video game, or something like Microsoft Word. All of those things are full-on, built-out, complex applications that are more formally produced, usually by teams. One way to distinguish between scripts and programs is oftentimes scripts are written by one person for one person's use, whereas programs tend to be at least a few people, if not dozens or hundreds of people. And that's not fully determinative, but it's one way to kind of look at it. One's a lot more complicated than the other. So we focus on basically scripting in Python because it helps us basically accomplish a variety of different tasks within all of the other topics, whether it's network security, systems, applications, logs, crypto, any of those things. Understanding all of that stuff is important, and applying Python to it is important. The other thing that's important about understanding programming concepts. So by understanding Python and programming itself, the general ideas behind it, another thing that we do is reverse engineering. When we try to understand what a new piece of malware is doing, it's good to understand the basics of programming. We do reverse engineering, where we open up software and try to figure out how it's written, where it came from, and a variety of other pieces of information, so that we can either prevent against it, or duplicate it, or work with it and understand it. So basic understanding of programming just permeates everything that we do, because everything is based on programming. The last thing I want to focus on too is, although it's not a separate topic in and of itself, is our capstone project experience. So if you were to join us, you would study those 8 different topics pretty much simultaneously, never more than about 4 or 5 at once. What we do is we take our 15-week program and we chunk it down into 5 what we call phases, 5 3-week phases. And you'd focus on 3 or 4 of the different topics at a time, and then each phase builds on each other phase. Usually we team teach. There's 2 instructors at a time. Lately, this last year, I've been teaching with a fellow named Adam, who's located in Colorado, and we have a fine time. Usually we split up the topics, and he'll cover a couple and I'll cover a couple, and it works out really well. Just to give you a glimpse of what leads to the capstone project, within each of those phases in our online live program, what would happen is basically it's like a work day for you. We have a schedule from 10 o'clock in the morning to 7 p.m. We have a 2 o'clock lunch break, and 2 4-hour blocks of time, morning and afternoon. And basically, there's 2 lectures a day and 2 labs a day. If you do the math on that, that is roughly 150. I'm sorry, getting this wrong. That is 10 lectures across. Right, there's 150 lectures or so, roughly, across 15 weeks and 150 labs. There's a variety of other things that happen too, but basically, plenty of stuff to do across 15 weeks. And so basically we spend about a given day, say it's your first day, would be a 9 o'clock lecture, usually up to 2 hours, and then a 2-hour lab period that builds on whatever that topic was, a lunch period, and then another 2 hours with a second lecture and a second lab in the afternoon. That repeats throughout the week. At the end of a 3-week cycle, there is a gating process, or basically, I hate to use the word exams, but it's hard to get away from that. Assessments, basically making sure that everybody is getting out of the program what they need to. If at all, if you're at any time having any difficulties or problems, getting on top of anything, we're always available to help you all day long. Adam and I are available, or any of the other instructors, depending on who you're being taught by, are available in Slack, in Zoom, and other ways. And we're very, very hands-on, even though we never physically meet. And I see there's a question from Nadine. Nadine asks, is there a part-time option? Yeah, that is covered on the website, but really quick, I did mention this at the top, but for everybody else, the part-time option we call the flex option. So there's a live option to review the 2 options. There's a live option that's 15 weeks long. Basically, that's like a work day for 15 solid weeks. The The part-time option is called flex, and you have up to 40 weeks to complete that. That's relatively self-paced. I say relatively because it's not the kind of thing you can sign up for. And on, say you started on February 1st, you can't just sort of go for 30 weeks without doing anything and then try to cram it all. So even if you were to do the one of the flex options or the flex option for our program, you have an instructor and it's asynchronous. There is live time. However, you got to stay on top of yourself, and our system helps you do that, and our instructors help you do that. But it's a different experience because it's much more self-driven than the live program. The live program you sign up for, you show up at 9 o'clock on Zoom like we are here, and on Slack, and get the work done. Not to say it's not like drinking from a fire hose, it certainly is in the live program, but if you don't stay on top of the milestones in the flex program, it can get to a point where you can't possibly finish, and you unfortunately, that wouldn't be good for you. A couple other questions. So that was a part-time question. What time zones are the classes based on? Yes, the classes are based on East Coast time, Eastern Standard Time, which I happen to be in because I'm in New York State, which works well for me. But we have students from around the world and mostly across the country. This last cohort that I wrapped up a few weeks or so ago, we had people everywhere from Maine to San Diego and Florida to Washington and every place in between. And we recently, literally as of this month, we changed our timing a little bit so that we work on a 10 a.m. to 7 p.m. schedule, 10 a.m. to 7 p.m. schedule based on Eastern time. So if you are on the East Coast or Eastern time, you would start at 10 a.m. And work until 7 p.m. if you're doing the live program. The flex program you can do any time of the day as long as you stay on top of the flow of things. So if you're in Central, then you're at 9 a.m. If you're in Mountain, you're at 8 a.m. And if you're on Pacific time, you start at 7 a.m. So those are all the possibilities here. I see somebody's asking about how much the program is. General costs are on the website. I don't have that stuff off the top of my head, mostly because it's not what I focus on as an instructor, and things do sometimes change. What I would suggest is that you contact admissions, and they've got all those details. Usually the next question after how much is the program is how much help is there for the program, and all of that stuff is available out there too. I'm not sure what scholarships, grants, or any other loans or that sort of stuff is out there, but basic information is on the website, and certainly if you contact admissions, you can certainly dive in and get that. I'll cover a few more program questions and then dive into the second half of my chat here. Yeah, I see that someone's asking whether the program is good for someone with a high school degree. I would say that the program is good for someone without a high school degree. One of the things we talk about as instructors here a lot, and as lifelong learners and non-traditional learners, is the idea of grit. The idea of basically, being able to pull yourself along regardless of what your formal education is. I clearly have more degrees than I know what to do with, but that doesn't mean you can't be successful. I know lots and lots of people who are quite successful with a high school degree, and that's in our particular program. And specifically the cohort that I just finished, we literally had a fellow in San Diego a young man who had literally this past spring graduated high school and weighed his options with his family, go to college or do this, spend 4 or 5 years and tens of thousands of dollars, or 15 weeks and do this and see how it goes. You can always go to college later. Nothing prevents you from doing that. And he did great. And while we're on that topic, we have people from 18, although I will say the younger folks are a little rare. We tend to have people in their 20s and 30s, but we literally know my last cohort had from 18 to late 50s. A fellow a little bit older than me who did some other stuff in life and decided to pivot here later in life for him. So, basically, if you have the drive and you've got a computer and an internet connection, this is doable. There's no part of this that's not doable, mostly because what we do is, like I said, just like what I'm doing here, chunking things down into small digestible bits. All of our lectures, and again, I don't even like the word lectures. They're really more like informal talks like you would have in a workplace. That's the other thing about our experience is that, sure, yeah, it's a class at 9 o'clock or whatever, or 10 o'clock in the morning. But we run it differently. We run it like one would run an actual business. You show up here and we treat you more like a colleague and a coworker. And my role is more of like a manager that brings you along and gives you information that you need to get your work done. So, and so it's just a different model of teaching. I've taught stand-up in-person classes for years at the university level. I've taught them online, and I've taught in the boot camp space. And this is a vastly different thing. So, if anybody wants to talk in any more detail, let me drop my name here in case you didn't catch it. I'm on LinkedIn. And here's my email. There you go. And I'm on LinkedIn as well. If you just search for Joseph Gallowitz, there's only one out there on LinkedIn, and feel free to connect with me there. So, anyways, yeah, perfectly fine for any level of experience. And again, we've got college graduates, we've got people who used to be in business, and like I said, everything else in between. Few more questions, and then I'm going to pause the questions and come back to them. But I really appreciate this. Is great engagement. It's nice to see
Joseph,
everything.
if you want to check in the actual Q&A, there's like 3 questions in there waiting.
Oh, okay. Thanks. Oh, great. Okay, let me clear this real quick and just. Okay. Yep, high school. Are there grades or is it pass fail? It is essentially pass fail. That said, we do not have a GPA. That doesn't mean that if you make one mistake, you fail, though. At each phase, it is possible by policy to fail. And, we have very high standards because we have relationships. But we want to do well by you, and we want to do well by your future employers. We have many relationships across the enterprise world, from companies from Amazon to Zillow and everybody in between, that hire people like our people. And so we want to make sure that, we ensure success for you and for them. That said, like I said, from day one to the very last minute, instructors are there to help you along. So that doesn't mean we handhold, but it's a challenging program. But we have 3-week phases, and well before you get to your first assessment, we will be talking to you on a regular basis about how you're doing, and you will know on a daily basis where you're at. And anybody that's close to, quote, Not completing. I don't like to use the word failure either. Not completing is we make sure you get what you need to do to help you in the situation. When I say not complete, the only people I've ever seen not complete are people who have been challenged by stuff that happens in life, or that just didn't want to do it. To be real honest about it. If you have the drive and the commitment to strap in and do this for 15 weeks, you're gonna pass, and you're gonna do well. The thing that the two conditions that happen that I've seen is, people still get COVID, people have sick parents, people have children, people have deaths in the family. Life happens, okay, and that happens everywhere, and we have policies to deal with that stuff too. So that's not the idea of failing. You pretty much have to try to fail. The other condition is basically you don't show up, or you basically just are half-hearted about it. And just like anything else in life, if you don't bring it, you're not going to get the reward out of it. So you get out of it what you put into it. A few more questions, and we'll get back to what I was talking about. In case you didn't notice, Corey did post the admissions information. How can I combine data science with cybersecurity? I'm currently a data scientist. Well, that is awesome, Daniel. As it happens, I'm actually literally starting the data science program myself here on the part-time basis, just because I'm curious about it. So I'm kind of going the other way. So how can you combine it? The fact of the matter is they're kind of combined automatically because of systems like Splunk, what I was talking about earlier, logging and SIMs, that artificial intelligence and all that stuff is sort of baked into the software that we use. The question is how deep are you into data science in the application of it? Are you using it to get results, or are you actually doing the coding and projects that make things happen? I'm doing the program just because I'm curious, and I've got 40 weeks to do it, so I'm going to spend some time on it in my evenings and weekends. But having the data science background is fantastic, because if all like someone like yourself could do is go on the Splunk website or LinkedIn or Indeed and look for, and I have not done this, so you can prove me wrong, but I'm pretty sure if you go and I spend a lot of time focusing on jobs and what's available out there. If you go out and type data scientist and cybersecurity in a job search website, it's probably going to explode with opportunity there too, because so much of what we do is driven by AI and all that stuff. A few more questions. Man, this is great. Prerequisites. You got to be able to use a computer. We do have a, when I say use a computer, what I tell people is basically, if you can do your banking, okay, online, and understand how to log into a secure website, and point and click, and do basic stuff that we do every day as just normal people, not programming, no nothing, that's all you need. When you, as part of the admissions process, there is a evaluation that we give, just to give an idea of kind of where you're at technologically, because one of the things we do is fill in gaps, and we assume that everybody comes in completely not aware of much of what we do, that they have just that basic computer literacy that hopefully you already have. I mean, anybody that made it to this Zoom is qualified to do our program, basically. But now I'm sorry, I'm focused on the next question all of a sudden. So yeah, if you can use a computer, you're good to go. And then, all right, so once admissions is done and you're actually in, we have what's called a prep program, okay? Prep is, depending on the program, and it changes a little bit, we're constantly improving our program, so things fluctuate a little bit. But basically, a number of basic computer literacy types of things, and networking and applications and system stuff that kind of give you a basic foundation before your program proper starts. So it's not like you just sign up, pay your fee, and then go from 0 to 100 miles an hour on day one. There is a prep program that we provide, and that's bundled into what we do. There's no extra charge for that. It is, of course, appropriate for someone who has a CISSP with a background in programming. Absolutely not, Hamid. If you have a CISSP, what a CISSP is, for everybody else who doesn't know what that is, I always forget what the letters stand for, but a CISSP is a certification for managers in cybersecurity and folks like myself in legal that deal with policies and running a business. Usually CIS, in fact, in order to get a CISSP credential, you have to have several years of solid experience in not just one, but at least two of the subject areas of cybersecurity, the subject areas we just covered. And you should be way beyond what we're talking about here in our program. So again, if you want to hook up with me here, like I said, I have enough information to kind of point you in other directions, but I would definitely say that you'd be overqualified for what we're doing here. Okay, it's almost 7 o'clock on the East Coast, so I'll make sure I get through my talk. We will return to a couple of these. I see the ones in the chat. We're going to come back to this stuff. Okay. You're welcome, Hamid. Okay, so here's what we're going to do. So the capstone experience, basically, can everybody still see my screen, hopefully? So the capstone experience brings it all together in the end. It's the last 3 weeks of our program, and while you finish a couple of other topics, basically everybody's broken down into teams. We have a simulated network environment, and you basically work as a small cybersecurity company that's been invited in to solve the problems of a small business in terms of cybersecurity. Basically, everything's gone wrong, and you guys have to figure it out. One or both of the instructors act as your chief information security officer, and when I act that role, I tend to be sort of a clueless manager that basically gives you lots of stuff to do and expects you to do the impossible and then come back and prove it. So, but it's a lot of fun. It's basically like playing Dungeons and Dragons in the IT cyber world for 3 weeks, figuring out, who did what and how to fix it. All right, so let's focus down to the second half of this, which is the fun part of this, which is why is Python important? Now, we've learned, if you signed up for this, you probably have either heard of Python or someone told you Python's important. What is Python really about? Python is a general programming language, okay? It's what is very, very popular today. It could be something different 20 years from now. In fact, 20 years ago, Python was barely a thing. Somebody decided that there was a better way to program, and they started from scratch. And I could get into a lot more detail, but I'm not going to. The point is, Python has become a very, very, very important programming language. There are many, many others. We use Python because it's everywhere, and it's easy. It's a great first language to learn because it's easy to learn and implement. It's open source. There's tons of free learning resources. Because it's what everybody uses, employers like it. It's easy to get up to speed. Teams can work easily. Lots and lots of libraries of code out there. And you can basically do just about anything. But that's true for any programming language. So while I'm talking about Python, you can pretty much fill in the blank with just about C++ or C. And in fact, Python is written on top of other programming languages. So I just want to make sure that's clear. Many of the most famous websites and applications that you deal with and that you're all probably, fiddling on your phones with on a daily basis are written in Python. Netflix, Google, YouTube, Instagram, Uber, Spotify, Instacart. That's the hit parade of my phone. It's all Python, but it's basically the whole point of this is that all programming is actually the same. For the last 70 or so years, since the idea of how digital programming ever was a thing back in the 40s, we're really talking about a very few concepts repeated over and over. And so when I first started teaching, went back to teaching IT and cyber stuff, I realized that all the programming courses I took put me to sleep. And why was that? It was because that they just got way too complicated way too fast when the concepts are actually pretty straightforward. So I came up with what I'm about to give you here, which is what I call the 10 and 10, the building blocks of coding. There are actually only three. Absolutely, this is true. Go look it up. Three concepts that all coding that's ever been done are built upon, and they're very easy to explain. The next seven all build on those. They're all very easy topics, and I can actually cover them all in less than 10 minutes. So that's the point here. It is 7 o'clock. I usually go a little long because I go off a little bit. For the next 10 minutes, my challenge is to give you in 10 minutes the 10 basics of coding. All right. So what's coding? Instructions are based on simple concepts that build on to express ideas or solve problems. Here's the thing. We'd all love to have invented Google, right? But somebody did that already. Somebody had that idea in the late 90s, and they sat down and they started coding something. And they wrote one line, and they wrote another line, and they wrote another line, and it built up to the thing that we understand is, Google today. But it has to start with an idea. See, the thing about coding is it's just a language. That's why they call programming languages. So you're just communicating, but you're communicating with a computer. That's what you're doing when you're coding. And what we're basically doing is just manipulating very small pieces of information, but we're doing it over and over and over again in order to do something big. So more specifically, a programming language is just a set of instructions that humans use to communicate with machines, okay? And learn one, and Python's a great one to learn because it's relatively easy to use. You get exposed to all those topics I just talked about, and you can apply that to other programming languages that have more specific applications. Computer scientist, computer science pioneer, I don't think he would have been called a computer scientist at the time because he invented the concept. Alan Turing is an Englishman who proved that a workable computer needs only three features: variables, being able to read and write from some sort of storage; logic, being able to compare values to make some sort of decisions, comparing two things; and then looping, being able to repeat something two or more times in order to do stuff. Python builds on those three things. In fact, those three things are right here at the top of this list: variables, logic, and loops. After that, you need input and output. You need to be able to communicate those instructions to a machine, and then you need to be able to get what the machine gives you in order to have some sort of output. And by the way, there's nothing different between this and a video game. I'm a big video gamer. Been gaming and programming games for literally over 30 years. All of this stuff, there's no difference between, playing Call of Duty or writing a piece of malware or reverse engineering a piece of malware. It's all just code. So whether you're inputting and outputting from a keyboard and a screen, or, with an Xbox controller and a flat panel on your wall, it's the same thing. It's just input and output. Methods, functions, and objects. They're really the same concept. Basically, how do we encapsulate code into reusable pieces to make our lives easier? Storage. When we're done with it at the end of the day or as we're working, over the course of time, or you want to save a game or save the novel that you're working on, you need to store it somewhere. And then finally, errors. Those are all the 10 topics that anybody's ever going to talk to you about in any computer programming world. It all gets a lot more complicated. Each one of these things is a topic in and of itself in a real computer engineering, programming a program on the university level. You can spend, years studying all these things, but these are the basic concepts. It doesn't get more complicated than this. It just gets more detailed. So variables are labeled spaces in computer storage that can be examined and manipulated to make decisions. In this case, we have a little code snippet, x equals 5. Print x is what we call the function. If we were to actually put this into an integrated development environment like PyCharm, which is basically like a word processor for programmers, we would get the output of 5. X5 is stored in x. We want to retrieve it. We're going to print it to output. We get number 5. Logic, in this case, comparing two statements in order to make a decision. Okay, believe it or not, whatever screen you're looking at me at right now, okay, your computer, your phone, your tablet, your TV, whatever you're looking at me right now, is literally making billions of decisions a second. For everything from where your mouse cursor is placed, or whether you just typed something in the chat, or whether a particular pixel needs to be changed from one color to another, everything is constantly being, just a constant series of decisions being made. A lot of people don't realize that when a program is being run, even if your computer is just sitting here waiting for you to do something, even waiting is making a decision. As long as the user is not doing anything, okay, I'm just a computer, I'm just going to sit here. But if you touch the mouse or you click the keyboard, now I'm going to do something else. Those are just decisions. And all that boils down to an if statement. If Joseph clicked the mouse, do this. If Joseph did not click the mouse, don't do anything. It just gets more complicated than that. The point is that by repetition and lots of little tiny decisions, you get big results. Loops. Again, a computer is basically just sitting there waiting for you to do something, or a video game waiting for you to take the next shot or move your character or whatever your thing is. It's literally just looping, waiting for you to do something and make the decision to do something else. So like I said, variables, what's the current state of memory? In this case, the smallest thing I can possibly demonstrate, x equals 5. But in terms of a Word document or a video game, it could be the entire game state of whatever you're doing, in Overwatch. There's a whole constellation of memory that's holding your game state until something changes. And something changes is when the game is sitting there trying to tell you, trying to make the decision of what to do next. Did you take the shot right? Did you make a headshot? Did you type a sentence? Whatever the thing is, there's some logic going on, and it's constantly looping. That's the basis of all programming. Beyond that, again, input, how we interact with the program, whether that is with a keyboard and a mouse, whether that is touching my touch screen, whether that is using a game controller, whether that is talking to Google on your phone, whatever that is, there's some sort of inner input that you need in order to give the computer to do something, to get something done. And of course, the opposite is output. If you put the correct input in your bank website, the proper password, or maybe your fingerprint, you're going to get in. And the output is going to be your access to your bank. If you don't put the right password in, you're not going to get the output you want. I group 6, 7, and 8, reusability, methods, functions, and objects, basically different related ways of taking code and putting it together into snippets, or sometimes very large chunks of code in order to do some particular thing. And here, you want my game tag? Here it is. All right. Objects, right? So basically, reusable code. The thing is that say, in terms of cybersecurity, if you wanted you want to infect the world with the latest and greatest piece of software that's going to create havoc, you need to be able to distribute that. And that means reusability, having something go from one computer to the next computer to the next computer and infect it in order to do something. That's just one version of reusability. Another reusability is I create a script to do some particular mundane chore easily, and then I share it with other people who need to do the same sort of thing and get some benefit out of that. So all programming is basically, modern programming is all based on this idea of objects, that basically we encapsulate programs in order to reuse them. Files, writing and retrieving information from files for long-term storage. Again, that's basically just sort of a deeper level of input and output, storing something somewhere. Again, whether you're writing the great American novel, a business proposition, a website, an application itself, a video game, whatever you're doing, it's got to get stored somewhere, and that's storage. Finally, error handling. I saw literally this afternoon saw a cartoon of a software engineer, something along the lines of spend 2 hours coding and 6 hours debugging, finding errors. We're human. This stuff is not easy, but if you break it down into little pieces, it's doable. And error handling is part of that. And built into Python and other programming languages are error handling systems that allow us to catch the problems that we create as we do things on a computer. And when we say error handling, so even error is sometimes too specific a word, because we oftentimes think through a problem, code it, and then realize it's not actually doing what we thought we wanted it to. Then we have to make some adjustments. But that's essentially it. The top 10 of the 10 concepts of all computer programming. Getting started with Python, like I said, today is not a coding demo at all. However, if you want to dive in real quick, you can go to fani.org. If memory serves, this is from NIT. Fani is type it right. Fani is a integrated development environment that's completely free. Developed at MIT, and it's pretty robust, and you can get into programming very, very quickly. You can download that. It's a quick install. I mean, literally about 60 seconds. Launch it, and you can start coding. There's lots and lots of tutorials out there. LinkedIn Learning is one that I love. Pluralsight's another. There's Try Hack Me. There's dozens of ways to dive into programming. Let me switch my screen just as a quick peek. So over here, you should see a couple of white panels. This is what's called PyCharm, a much more robust software development environment for that's focused on Python. And an integrated development environment, again, this is just for those of you who want to tinker for the evening or the weekend. You can get PyCharm for free. You can also pay for heavy duty levels of it. But any of these tools will get you going. Here at the top, you'll see the traditional piece of code that people use in the programming world to determine whether or not the thing is even working. So I have a file here called helloworld.py, py short for Python. I'm going to clear my output here on the right side. I'm going to run this little program. There we go. I got the output of hello world. So we know my IDE works. here is my an example from the slide earlier of a logic of basically I was basic on if statement as you can get. I have a variable equal to 8. If the variable is equal to 8, print the variable is whatever the variable is at the time. Otherwise, print that didn't work. So let's see, my variable is 8. Let's see if this works. I'll clear my output. The variable is 8. Let's change the variable to something like whatever. And run it again. That didn't work. There we go. So I'll post my LinkedIn in a minute, you guys, in case you can't find me. But that's PyCharm, and those are just a couple different ways to get into programming. Again, what we want to do here is introduce you both to Flatiron generally, our program in cybersecurity more specifically, give you some insight into how Python and programming generally plugs into all of that, and give you an overview of programming, and also my own particular approach to teaching, which is that is to break things down into very small, understandable topics. So literally the first 10 minutes of my Python course is those 10 topics there. And then we pick each of those things apart as we move along through the different phases, and we apply them. I find that people's response to that method is pretty positive. Okay, so I see a few more questions, actually a lot more questions. Let's see. Let me get my, let me post my LinkedIn for you. Okay, I just posted my LinkedIn link to the chat. So please feel free to connect with me. As I said, at the end of this chat, just so it's not lost, I will post my email address again. But feel free to connect with me and that sort of stuff. So let me slide up here. Corey, you still out there?
I am still here. My kid's watching Boss Baby in the background.
No problem. Okay, I see you answered a few of these. Okay, great. Is that right? Okay, cool. Okay. The course is more of a high-level overview, or will this include industry practical tools and procedures? Both is the short answer. Yeah, we always start with a high-level overview, kind of like what I did today, just to give you the lay of the land, and so that you have some understanding about where all this fits. But yeah, we use everything from Splunk to the Kali instance of Linux, which is a tool set that cybersecurity people and hackers use in cybersecurity, and everything in between. So yeah, everything from the biggest, broadest concepts to nuts and bolts of each of those different topics I covered earlier is covered throughout our program. That said, one of the things that we emphasize across all of our programs is this idea of being a lifelong learner. You can't really, survive in IT or pretty much in any discipline anymore by just going to school and thinking you're going to do that thing, whatever it is, for the next 40 years or even 4. Things change constantly and things evolve constantly. And so, one of the big things we do is we focus on learning how to learn, how to bootstrap yourself, how to do research, how to utilize the various resources that are out there, how to network. The 18-year-old student that I described earlier, he'd never hung out online with people in their 30s, 40s, and 50s. And he had to figure out pretty quick how to assert himself, with people much older than he was, and it worked out just fine. But the point is that we do push, collaboration and working together in a professional environment. So, what else have we got? Scrolling too fast here. Hang on. Yeah, this is a good question, Doug. So Doug asks, is there assistance landing a job in the field after graduating from the program? The short answer to that is yes. And in fact, we start this talking about the job hunt on the first day. Again, that's not the kind of thing where you learn a bunch of stuff, wake up the next day, and then go look for a job. I myself have made it a lifelong project that I touch my resume actually pretty much every week. I'm forever touching stuff up. And nowadays, with everything on LinkedIn, if you're not updating your socials, if you're not updating your resume, if you're not out there looking for your next opportunity, you're probably going to miss one. So literally, yes, we have a formal job placement program and individuals on staff that will help you for months after graduation. You'll find out that we'd like to build a very collegial and collaborative community too. So whether it is with the instructors, whether it is with your fellow students, whether it's anybody else, that networking is invaluable. But also throughout the program, in addition to the program, whether it's cyber or the other ones, each phase features a different part of the job readiness process. So, for example, building a social media presence on LinkedIn is one project that we do. Writing a resume is another one we do. Actually searching for jobs is another thing we do, and several other things. So throughout the program, you're working on those things as well, so that by the time you get to the end of the fourth phase, you should have an online presence and a resume and some really good ideas about where you want to go and what you want to do, so that by the time graduation rolls around, you can literally wake up the next day and hit the ground running. So thank you, Jonathan. Appreciate the comment. Do you have a way to get internships at these companies like Amazon or any other? Well, again, formally, no. So like, unlike, the university that I teach at here in Rochester, where there are semester by semester based cooperative opportunities, and other universities have that sort of thing. We don't have that sort of thing. But that said, there's lots of industry relationships. And so depending on what's available, we hear of things all the time, and people get either jobs and sometimes internships. We're more when I hear internship, I really tend to think of the more formal education process, because we aim here to have you prepared in 15 weeks to be well beyond an internship. The way I look at our entire experience, including the capstone piece at the end, is you're already in an internship, okay? Especially after the first 12 weeks. And it's that 3 weeks at the end that really, light the candle and get you on your way. The fact of the matter is that, Amazon and Microsoft and all those, top shelf companies that anybody would, love to work at. You can find all sorts of opportunities right on their websites, on Indeed, everywhere, so you're not going to get internships through us.
I listed the like internship style that we did, like the partnership we did with Deloitte, which isn't really like an internship. It's you going and getting taught through their program and getting hired. But internship-esque, I guess, is like the best way to put it. But that's
Yeah.
what it is right now. But to give people an example of like some of the partnerships that we have with some of these larger organizations, I added that to the chat. And I can put it back in there. But that's also all on our website, or you can Google Deloitte and Flatiron and kind of see one of the programs that we've done. And we've done that with a couple other companies. I'm just spacing on names right at the top of my head.
Yeah, no, and again, the way I look at it is the way I look at internships. And certainly, lots of people get jobs after internships, but to me, an internship is almost like there's no promise of a job or that sort of thing, Whereas like the Deloitte program was like that's sort of like a work to hire kind
Yeah.
of thing. So to me, that's a much more formal. I'd rather do that than an internship if I had one of the two to pick, right? Because that's a pipeline right to a serious job. And so, yeah, that's a very exciting program and definitely worth, checking out. And again, hit me up on LinkedIn. I'll drop my email again if you want any more information. I'll be happy. Internships. I'm so glad you mentioned, older students. Daniel writes, I'm so glad you mentioned older classmates because I was wondering if a middle-age pivot would be worth it. Well, I mean, look, if you're already Elon Musk, Daniel, probably not. But it depends, again, hit me up. Like I said, I went to law school in middle age 20 years or so ago. I'm all about pivots. I do a lot of different things, not just this. So, this is my focus during the day right now and will be for a while. But, I like doing a lot of different things. And so kind of depends on where you're at. I talk to people about this issue all the time, whether it's in IT, whether it's in cyber, whether it's in law enforcement, whether it's in the legal practice. So, those sorts of decisions are very personal, but I'm happy to talk to it. If you're not happy with how much you're making today, if you want to do something exciting that's growing and you just want to do something brand new, and you got 15 weeks to devote, that's not to me a huge time investment. But yeah, the very, very idiosyncratic sort of thing. But again, hit me up. I'm glad to talk to you anytime. Uh, so someone asked about certifications and that sort of stuff. And so I agree with Christian who writes about sort of what things are, and provides his opinion on different security certifications and that sort of thing. No one training program, whether that is a bachelor's degree, a master's degree, a PhD, a particular certification, is going to get you a job. One of the things I want to point out is that they're not just jobs with what we would call hands on keyboard and eyes on glass. Take just one company, for example, Splunk. Splunk is if you've ever seen the word, is a massive cybersecurity and artificial intelligence and data gathering and processing firm that cybersecurity is just one part of what they do now. And all of these companies need HR, need marketing, need training. So here's the other thing too, back to Daniel's question about a mid-career pivot. I've literally had people with master's degrees and teaching credentials decide I don't like dealing with third graders anymore, but I'm a really good teacher. do a program like this and become a cybersecurity trainer and make bank. Okay, I've had people from marketing world decide, I kind of like this stuff. I don't want to be a nerd, but I see all sorts of jobs for marketing people in cybersecurity. There, all these companies need HR. All these companies need payroll. All these companies need everything that every other company that's ever existed needed, legal, all that stuff. So yeah, this gives you a great base, and I've seen people come right out of our program and programs just like these get amazing jobs, and some people don't, or it takes them a long time. That's true in any uh, discipline or endeavor. There's an ongoing sort of debate, and there's no way to, solve it. Do you need certifications like Security Plus or Network Plus or CISSP or that sort of thing? Who knows? I've a colleague of mine here who I've had speak to classes alum of the university here that I teach at. Basically built the cybersecurity arm of IBM over the last 30 years. And somebody asked him the question, certifications or not? And the guy's like, don't care. Okay. Don't care. What he wants is grit. Okay. Back to where I started this thing is, can you show me you can solve a problem? Can you show me that you're going to show up day to day to day and work your ass off? Okay. And solve problems in a collegial, cooperative, and respectful way to get stuff done. That's true anywhere. Okay. Me personally, I've hired and fired dozens of people in my time in the businesses that I've owned and been part of. And I will hire the person with the less impressive pedigree any day that impresses me as the person who can get something done than the person that's just got, a whole bunch of, alphabet soup on their resume. And I think that's true in a lot of different places.